Hi everyone. So this is not going to take very long. The idea here is that numbers in physics do not mean the same as numbers in math. Let me, for example, talk about my height. Now, when I write that my height is 1.80, this has a very precise meaning. The meaning of this is that I am absolutely sure that my size is somewhere between 1.795 and 1.805. What if I write 1.8? Now in math, this would mean exactly the same thing. It's the same number. Here, there's just one more decimal, but this decimal is a 0. So for a mathematician, these two numbers mean exactly the same. Not for a physicist. For a physicist, this means, well, now I know that my height is around 180, but I could be off by this much. This could be up to 1.85 and as low as 1.75. You see that this is a huge difference. Here, I am 10 times more sure about my height than I am here. The idea is that here my uncertainty is around 1 centimeter, and here my uncertainty is around 10 centimeters. So the idea is that basically that the last figure that I write tells me about how uncertain I am about the quantity that I am writing about. So basically this unit is telling me the uncertainty in my quantity. Now, in order to do this, we need to have a very clear system in physics so that when I see a number, I know exactly where it comes from. Because in physics, every single number comes from a measurement. Maybe not straight from a measurement, maybe you had to do some calculations to arrive at it, but eventually, if you go deep enough, you will see that that number was obtained from some sort of measurement. And therefore, the precision that we have in this number, this or this, is fundamental. You cannot ignore it. Now, in physics, the way that we use so that it's impossible to get confused is to just use standard form. Remember, we started standard form last year, and the thing about standard form is that it makes it very clear how much precision your number has. So you always start with the first number, 3, and then 0.5, and then whatever is after the comma is a significant figure. It means that it's a number that has meaning, that tells me, yeah, this is not just a random 0. I actually do think that this number is close to 0. And if I have 3 zeros, this is way more precise than if I only have 1 0. And this doesn't mean this is around 3.5. This is really around 3.5000. So this is the way that we signal the precision in our figures. Now, we're not always very good at that. And this means that sometimes you will see numbers that are not expressed in standard form, and you need to be able to decipher what they mean. Now the basic idea is this. If I see a number, let's just say 350, this 0 here is not a significant figure. So I would say this number has two significant figures. If I see the number 3500, again, these two numbers are not significant. So any number that's a 0 that is before the comma just is not a significant number. However, if I have 350.0, now it turns out that these two numbers are now significant because I have a 0 after the comma. So basically any 0 after the comma is significant, and of course if there were zeros before that, then those zeros become significant straight away. In this sense, if you ever see something like 200 times 43, you need to be aware of how many significant figures each number has. And this is very important in the way you express your results. Let me explain to you why. So first thing, this one has two zeros, but they're both before the comma, so it has only one significant figure. So I'm going to circle it with blue. This one has two figures, there's no comma, so they're both significant figures. So now we have one significant figure and two significant figures. And now I ask myself, well, if I need to write the result of this thing, how many significant figures should I use? Should I use 2? Should I use 1? Now the rule of thumb is that you should always use the minimum amount. So if this one has 2 and this one has 1, then your results should only have one significant figure. If they both have 2, then your results should have 2. If one has 3, one has 2, then again your results should have 2. So you always use the minimum amount of significant figures. And the reason for this is that the uncertainty spreads out really quickly. So this number is really uncertain. When I multiply it by this one, this 3 is going to become completely irrelevant. It's going to become soaked in the uncertainty of this number, so that it really makes no sense to give 2 significant figures after the multiplication. So believe it or not, the result of multiplying these numbers is 8 and then 0, 0, 0. And this is not telling us that this is 8,000 straight. This is telling us it's 8,000, could be 8,500, could be 7,500, I'm not sure. These 3 zeros are not significant.